the first term, the second term, the third term, the fourth term. What will be the next, the fifth term in this sequence? These terms seem to be 9-digit numbers, but the spacing between the numbers suggests otherwise. They don't seem to be 9-digit numbers. Moreover, see how the numbers change. Each one seems to be an independent number. It looks like all the digits from 1 to 9 are simply arranged in some order. With that in mind, try dividing the 4 terms into 9 columns and compare them. A few patterns stand out. The first digit 1 and the middle digits 5 and 6 remain unchanged. Following this pattern, in the fifth term, this position should be 1, this one 5, and this one 6. In this column, 4 and 6 appear alternately, and in this column, 9 and 1 do the same. Following this pattern, in the fifth term, this position might be 4, and this one might be 9. These two columns contain the digits 2, 4, 6, and 8, arranged in different orders. And these two columns contain the digits 1, 3, 7, and 9, also arranged differently. There seems to be a pattern. However, we can't be certain. The pattern could change. Now, look at the first term. It contains all the digits from 1 to 9 in order. Try squaring each of them. Keep only the last digit of each value. This is the second term. Next, try cubing each number. Keep only the last digit of each result. This is the third term. Now, take each number and raise it to the fourth power. Keep only the last digits. This is the fourth term. Have you noticed the pattern? This sequence consists of the last digits of the powers of the numbers from 1 to 9. Therefore, the next term consists of the last digits of the fifth powers of these numbers. Here they are. This is my answer. Interestingly, when raising these numbers to the fifth power, the last digits appear in the exact order from 1 to 9. They are the same as those of the first term. What about the last digits of the sixth powers? Here they are. They turn out to be the same as the last digits of the squares. That makes sense. The last digit of the sixth power is the last digit of the fifth power, multiplied by itself once again. Since this is the same as the number itself, the last digit of the sixth power must match the last digit of the square. By the same logic, the last digits of the seventh powers are the same as those of the cubes. The last digits of repeated powers cycle every 4 steps. There's another fascinating property. The middle number between 1 and 9 is 5, and the last digits of powers are kind of symmetric around 5. Look at the first term. The distances from 5 are the same on both sides. The same is true for the second term, the third term, and the fourth term. The last digits of powers have these intriguing properties. This helps us easily find squares, cubes, square roots, and cube roots of natural numbers. I'm really curious to know your answer to this problem. Please write it in the comments.